Hi, hello. So today we're going to be doing the disruptant event known as the soda can crush. Um, to get this lab started, this demo started, all I did was put a little bit of water in some empty cans. I used seltzer cans and like a soda can, but any like small soda can will for a lab setting. So I put a little bit of water on each. It doesn't need to be precise. And we're heating it up. So it's on a hot plate and we're gonna let it heat up until there's a significant amount of vapor leaving the cans. It is just starting, so we'll be ready in just a minute. So while we're waiting for the water to turn into steam, so we're ready to do this, I wanted to adjust what types of questions the students would be answering in their notebooks at this time and what types of questions I would be asking them. So I'd be asking them what's happening inside the can right now. Most kids would tell me that the liquid water is turning into gas water, and that would be the first question. Oh, the first answer. I then might ask them, okay, so like if it's a gas, like how's it behaving? They'd be telling me it's moving fast, it's hitting the walls, it's causing pressure. We are in our gas unit when we do this lab. So they should be telling me that there's pressure. They should be telling me like fast, spread out, all those normal gas values. Once we kind of get through like what's going on inside the container, this will hopefully set the stage for them to make a reasonable hypothesis once they see the demonstration why it happened. So I am noticing my cans are just starting to steam, so we are going to go ahead and do this little demo. It is really important to use hot hands or tongs. I prefer these tongs. And when we do them to demonstrate the flip, it needs to be pretty vertical in here to make this work well. So we're going to quickly flip each can by itself into the ice bath. It's really important that this gets pretty cold. I think this probably could be colder, but I ran out of ice. So we're going to take the can, we're going to flip it and submerge it vertically. It's really important it's not at an angle. It'll let things escape that we don't want to escape. Yeah, so I'm going to go ahead and try it. I don't usually get to do this, but the kids do this. So we got one crush. I'm going to get the water out. So here one soda can crushes. Not my best. Let's go for number 2. This one's steaming pretty well. I think the ice bath just is not cold enough, but oh, this one went pretty well. All right, so that's can number 2, much better than can number 1. Now we'll try can number 3. Similar to can number 2. All right, so these are my 3 cans from the soda can crush. And now I'd be asking kids like why this just happened. So I would be in the lab notebook that they have, they'd be answering questions like, what happened to the gas particles when you put it inside of this ice bath? How did that affect the pressure? How would that affect the volume? And we're trying to relate all those ideal gas law concepts. Yeah, so the questions in the lab notebook are what happened to the gaseous water molecules when placed in the ice bath? And then also they're going to have to adjust how this affected the can's internal pressure. And then finally, the last question is they're going to have to be prompt with explaining like why this just happened. Why did the can crush on itself? And the next little while after they finish the lab notebook, or maybe while they're finishing their lab notebook, we typically have discussions including pressure and what happens when pressure changes rapidly in both flexible and inflexible containers. So they know when pressure changes in flexible containers like balloons, it just shrinks and expands. But when non-flexible containers, such as these cans, it becomes flexible, right? So it crushes itself to change the volume. So this is my demo. So we got 3, my opinion, well-crushed cans. This one probably needs more help. But here are soda can crushes.